Hello, Norman from Burton Electrotechnical here. In this video, I want to wire up one of our projects out of the workbook and go over testing it so that we know that we will not damage the fuse when we energize it. So what we'll do is we'll look at the drawing first and go from there. I have chosen exercise 1, which is a relay pilot control circuit. In this case, it has 3-wire control, so it seals in with a memory contact. So let's have a look at the fuse. The goal when wiring any electrical circuit is to commission it and start it up without damaging any protective devices. In this case, we have a small glass fuse that protects our control circuitry. The only way that fuse can be damaged is if it is overloaded. So if we exceed the current rating of the fuse by adding too many loads, the fuse will rupture. And the other way is if we have a short circuit. So in the case of, say, a wire was connected from one side of this run button across to the 0 volts, and then if somebody pushes that button, you will have a short circuit. You'll have a short circuit across the power supply, causing the fuse to rupture. Now we can test it before we energize it using an ohmmeter to see if we do in fact have a short or if we're all clear. The only thing that we need to know in the case of this test is the resistance of the load devices. And I will show you how to do that on the trainer unit. Okay, so the first thing that we are going to do is measure the resistance in the circuit. So we have a run relay, a green light, and a red light. The light, the power indicator light, is internal, and if you look closely, you'll see on the drawing there's 2 terminals. Those are the power takeoff terminals. So we're measuring everything downstream from there. So those 2 circles represent the power takeoff for the plus, in this case, the plus 24 and the 0 volts. So what we do, we get a meter set up, an ohm meter, and you can take a set of leads, plug it in, and the first thing I'll do is I'll measure the coil resistance. So pin 2 and pin 7. Now you would have done a pin exercise earlier in the workbook. We have about 440 ohms of resistance. Okay, so keep that in mind. And then I can measure the tower light, the resistance of the internal LEDs, but they're going to be very high. All right, so just for a reference, about 0.78 mega ohms, so about 787 kilo ohms, very high. So they'll use very small amount of current. Milliamps. Okay, so the coil is about 450 ohms, and about 780 kilo ohm for each LED. When I'm wiring in the field, I always tend to wire my commons first, and then I go line by line. So what I'll do is I'll look for pin 7 on the relay base, and I'll wire common to it, 0 volt, and then I'll find the common for the tower light and wire it. There's not a lot of common wiring in this circuit. So we'll come off from our power supply and we'll connect to pin 7 on the relay. And then from pin 7, we can connect over to the common for the tower light. Now we can start going line by line. So I'll just complete the wiring. I'm going to wire to the stop button. Stop button, in between the stop and the start, from the run button over to pin 2 on the relay base. And then from in between the stop and the run, I'll connect to pin 1 on the relay base. This is common. And then connect from 3 to the green light and from 4 to the red light, and then there'll be a jumper from pin 3 on the control relay to the other side of the run button, and that's our holding contact. Now, I have the circuit wired up and I haven't energized it. Before I energize it, I want to prove it out. So what I'm going to do is I'm going to disconnect where the circuit receives its current. So basically where the voltage source is, I'm going to disconnect, and now my meter is going to become the current source. So I got a little 9-volt battery in there, but that's all we need. We're going to measure the resistance. Now what we're seeing now, we're seeing resistance in the circuit already. So basically we've replaced the power supply with an ohmmeter. So we're measuring through here, through that normally closed contact on the control relay, through that red light. So if I unplug the red light on the tower light, or the signal tower, it will go into over limit. Now, when I push the start button, when I push this start button, I should have continuity through the coil. It shouldn't have any short circuits. So what I'll do is I'll push this button and I'll reach in behind here so I don't block it. And I have 435 ohms. Remember what we had? We had around 440 ohms or so. Changes with temperature, I guess. So another thing you can do too is you can operate the coil. There's a tab on the coil. You can zoom in a little bit. There's a tab and you can actually operate it. So now what I've done is I've closed the contacts, and if I had a short across here, it would show up. Okay, so I'll release that. And there we go. Now, time to energize, and I am 100% confident that this circuit will not damage a fuse. So I'll take this, where I receive my current for the circuit. It's the very beginning of the circuit. I'll put it back into the power supply, and you can do this in the field when you're commissioning circuits. It's called a cold loop check. Very, very useful startup test. So we'll energize the circuit. We'll start, stop. I strongly suggest that you wire this circuit up and you try to do it without looking at the diagram, and develop these skills for testing circuits before you power them up. It will really help when you're troubleshooting circuits down the road.